Hey guys, how you doing? Sorry I can't be here today. I've got to go to a PBIS coaches meeting for all secondary school coaches, and it just happened to fall on our first B day here of the second marking period. So I apologize, but I wanted to be able to give you almost as much as I was able to give my second block and sixth block classes by being able to go over our new topic, which is human population and its impact. This comes from chapter 6 in your book, and if you'll see on Google Classroom, one of the things I have assigned for you for next class is to make sure that you read chapter 6. So let's go ahead and move forward. All right, so at the beginning of each chapter, there is a core case study. And since we are dealing with human population, the core case study in chapter 6 does deal with China. Now, China was actually able to really combat its extreme population growth since the 1960s. They've put in a number of different government regulations, some controversial, some not so much. The controversial ones really where they were helping to promote one-child families through abortions and through sterilizations. Those were the little more controversial ones. But they did actually promote some benefits for having only one child, and those benefits were families were actually offered better housing. They had more food. They had free health care, salary bonuses for the parents, and then basically preferential job opportunities for the children as they grew older later in life. So, as a result of all this, China was able to cut its birth rate in half over a 40 year period. The average number of children that was born per woman, and that's like the total fertility rate, was 5.7 children in a woman's lifetime to only 1.5. Rapid industrialization has kind of happened during this whole time, um, causing a growth in the Chinese middle class. And based on what we know about our country and the way that we have, the more people we have with a greater prosperity, the more resources that are going to be used. The transition from a sustenance economy to almost a throwaway economy is happening in China, and it's causing a greater ecological footprint. So while they've brought their growth numbers down, the amounts of resources that they're using is continuing to increase. So some of the questions we need to consider during this unit is, why do we need to care about population growth? Well, I mean, every single person on the earth depends on all of the earth systems to meet our needs for, air, water, food, shelter, energy, all that good stuff. So as we continue to grow and there are more people on the planet, there's going to be more resources needed to be able to satisfy our, not just necessarily our needs, but our wants. And the wants part is really what goes into creating an ecological footprint. Currently, 1 out of every 5 people on the planet is not getting their basic resource needs met. So is it a question of the amount of resources available, or is it a question of the distribution of those resources that are available? Now, in 2050, basically we're looking at the possibility of there being 9 billion people on the planet. So if we continue this trend of 1 in 5 not being able to have their basic resource needs met, then that basically means that there are going to be almost 3 billion people on the planet that are not getting their basic resource needs met, which is pretty sad. All right, so some things about why the population maybe has grown exponentially over the last 200 years. Well, there are 3 major reasons. Reason number one is that we have, as humans, have developed the ability to be able to live pretty much anywhere on the planet. Okay, we're not just confined to warmer areas that are close to the equator. We can live pretty much everywhere. So that development, that ability to do so, has allowed us to continue to grow our population. Number two, early and modern agricultural development. We can actually grow more food on smaller bits of land. And then three, we've had to improve sanitation, improved healthcare, improved access to clean water, improved medical research, improved science in the terms of medicine and health, which have caused death rates to drop significantly, and in turn has caused life expectancy to become greater. So you have people living longer, not as many people dying, and so that rate drops off, and the distance between the number of people being born and the number of people dying increase, so therefore you've got more people. So the major thing to take away from this is over the last 100 years, because of industrialization and all this medical research, population growth has taken place because of this sharp drop in death rates, not because there's been more people born. All right, so human population dynamics. So more people on the Earth obviously means there's more pressure on Earth's natural systems. So here's a map of the world. Okay, we're talking about 7 billion people. Current rate of population growth is 1.1% per year. Okay, so that right there is taking a look at births minus deaths divided by 10. Okay, and when you talk about births and deaths, you're talking about births per 1,000 people on Earth, deaths per 1,000. The United States has just around 300 million people. Its growth rate is 0.97%. India, 1.2 billion people. Its growth rate is 1.5%. And China, 1.3 billion people. Its growth rate is 0.5%. So obviously you can see with India's growth rate being 1.5% and it only being about 100 million people behind China, it's going to quickly take over China as the #1 most populated place on Earth. Now, the United States is an interesting case because we are a more developed country. We are post-industrialization. Those countries tend to slow their population growth down and tend to approach zero population growth. For any of you guys who have taken AP Human Geo, you spent a bunch of time talking about population dynamics, demographic transition, things like that. The United States is still growing rather rapidly. I mean, our growth percentage is almost 1%. It's almost close to the current rate of world population growth. And basically the reasoning for that is it's not like we have a big difference between our birth rates and our death rates. They're actually pretty close. What we actually have is we have high immigration. So we have more people coming to this country every year, which causes our population numbers to continue to exponentially increase. So earlier I talked about total fertility rate in reference to China, where we talked about total fertility rate for Chinese women over the last 40 years has gone from 5.7 to about 1.5. Well, here's what that means. That total fertility rate is the number of live births that each woman of a nation will have during her lifetime. Okay, countries with low total fertility rates usually have low population growth. Okay, we talk a lot about replacement level. In more developed countries, replacement level is right around 2. Well, what exactly does replacement level mean? Well, that means that there are enough children born per woman to replace the woman and the father of that child. Okay, so 2 children are born to replace the 2 parents that will wind up dying later on. So it maintains a zero population growth model. In less developed countries, replacement level fertility rates are usually higher because in less developed countries you don't have the same kind of prenatal care, you don't have the same kind of medicine and health, so their infant mortality rates tend to be a little bit higher. Total fertility rate is lowest in countries that have low infant mortality rates and higher standards of living. Kind of makes sense. So things that affect total fertility rate. Okay, there are governmental policies which certainly are in place in less developed as well as more developed countries in terms of regulations regarding birth control, earlier policies that we talked about in China, but then mostly it's really cultural and economically developmental. And those two things do kind of go hand in hand. If you've got a country where women are achieving higher education levels and women are actually a major part of the economic landscape in terms of their earning potential, then you're going to wind up having lower total fertility rates. If you are living in a society where a woman's education and her career is stressed more, then those women will likely wind up having children later on in life because they've established their careers early on. So that's going to affect total fertility rate. Then there are some cultures where there is a more traditional, in terms of their culture, traditional view of women staying at home and having many children and taking care of the homestead. So it's certainly a cultural as well as governmental thing that can affect total fertility rate. A couple of terms that I want you to be able to differentiate between fecundity and fertility. First one we're going to talk about fertility, all right, is basically the number of women who gave birth in the previous year. Okay, that's the fertility rate. Here's an example. So you have 2.5 million women out of 136.7 million women overall gave birth in the year 2001. And the fertility rate for that year would be calculated by taking 2.5, which is 2.5 million, divided by 136.7, and then multiplying by 100%. So the total fertility rate, the fertility rate there would be 1.83% for that year. Fecundity, however, is determined by the number of women who have the potential to give birth in a year. And that's really where we're looking at the general landscape of what the population breakdowns look like. Number of women who have the potential to give birth in a year means that we are looking at women who are of reproductive age. So, expanding the example that we just did there, if there were 52.9 million women that were of reproductive age in 2001, okay, the U.S. Census Bureau says that reproductive age is between the ages of 15 and 44, then the fecundity rate would be calculated by 52.9 divided by 136.7 times 100%, and you get 38.7%. So fertility is actually how many women gave birth the previous year. Fecundity is more of a kind of looking at what is our population breakdown? Where do we see our numbers in our age groups? So smaller numbers in the fecundity area basically say, all right, well, they've got a smaller population, not as many people who fall into the category of actually being of reproductive age. All right, so we're going to start getting into some of the things that you're going to have to wind up doing today. We're going to look at the natural rate of increase of a population, and we're looking at crude birth rate, crude death rate. When we talk about natural annual rate of increase, that only is dealing with births and deaths. We're not dealing with immigration or emigration yet. So basically we're looking at natural annual rate of increase is the difference between the crude birth rate and the crude death rate of a population. So crude birth rate, number of childbirths per 1,000. Crude death rate, number of deaths per 1,000 people. So here's an example. If a population has a crude birth rate of 12 per 1,000 people and a crude death rate of 4 per 1,000 people, what is the natural annual percentage increase of its population? Well, the way that you would go about doing that is you would say 12 per 1,000 minus 4 per 1,000. Okay, so that's 12 minus 4 equals 8. Okay, so what I would then do is I would take 8 divided by 10 and then slap a percentage sign on it. Okay, and that's what it shows in the worksheets that you guys are going to be working on after we're done with this. So 8 divided by 10 is 0.8, and then slap a percentage sign on it. Do not make any decimal adjustments to your result. Okay, all you're doing is just dividing by 10 and you're slapping a percentage sign on it. Now, obviously, things affecting population growth rates, you've got advances in technology, you've got advances in economics, the Industrial Revolution, agricultural, medical advances, 21st century access to technology, all this stuff goes into bringing down your overall population growth rates. Doubling time. All right, doubling time is something that's commonly used in population dynamics. It basically says, based on current growth rates, how long is it going to take for the current population to double its current size? And the way we figure this out is we use the rule of 70. So the rule of 70 basically says that you have 70 divided by the percent population growth. Okay, so from that previous example we had 0.8% population growth. Okay, so we would go 70 divided by 0.8. When we figured out population growth rate on the previous slide, we just did 8 divided by 10 and then slapped a percentage sign on it. Here, we're going to take that 0.8%, and we're just going to remove the percentage sign. So it would be 70 divided by 0.8. I will guarantee you that there will probably wind up being some kind of growth rate calculation on the AP exam. Rule of 70, figuring out population growth rates. I guarantee you that'll be on the AP exam. So here's a couple of different things that we can practice. why don't you guys go ahead and work on practicing these rule of 70 problems and the growth rate, accounting for immigration and emigration. Now, accounting for immigration and emigration, all you're going to do is, instead of just doing birth rate minus death rate over 10, you're going to do birth rate plus immigrations, that's going to be in parentheses, minus death rate plus emigrations, and that's in parentheses. So you'll do the one minus the other. So it's always people coming in, which is births and immigration, minus people going out, deaths and emigration, and then divide by 10, slap a percentage sign on it. So I'm going to go ahead and stop this here. I am going to create another video that's going to go through a couple of the practice problems that you're going to wind up doing for homework for next time. Homework for next time, it's listed on Google Classroom, but you do have to read Chapter 6 and then make sure those 2 worksheets that you have when you picked up or were passed out to you during this class period, make sure those are done as well.